Hello, I'm Sam Fellows, and I will be talking about my team's senior project, the GVSU Solar Racing Car Chassis. I'll start by introducing the team briefly, then describing the key specifications for the project, next talking over some of the design elements, then speaking about the manufacturing of parts, the assembly of the car, and finally some of the testing. So to begin, I will introduce the team. Once again, my name is Sam, I'm an electrical engineer, and I'm the team captain. We then have Sammy, our team secretary, who is an interdisciplinary engineer, Oleana, who is also an interdisciplinary engineer, Cody, who is a computer engineer, and then our three mechanical engineers, Josh, Caleb, and Nicole. This project was proposed by the GVSU Solar Racing Team to use what parts they already owned and to manufacture or purchase new ones to build the suspension, steering, and braking systems for the car. The goal for this project was to have a rolling car so that the solar team could continue on with other systems, such as batteries and electrical systems, after the end of the project. We were originally given a budget of $2,000 for this project. This was later increased in an effort to complete the braking system. Parts provided to our group from the solar team included the carbon fiber shell, 3 wheels, a hub-mounted motor wheel, and 4 air shocks. There have been 2 major challenges with this project. The first being the budget. With this being a complex mechanical project, many parts were needed, whether purchased or machined, and due to the specificity of each part, they were not readily available in most cases. In an effort to reduce the price, we looked for cheaper suppliers, pre-produced parts, and second-hand parts we could use. But we were only capable of fully completing 2 of the main objectives, the steering and suspension, before the budget had to be increased and we could start completing what was able to be done with the braking system. The second challenge was the space and size constraints of the actual shell. It is a second-hand shell the solar team purchased from the Quebec Technical University Solar Racing Team. The physical constraints for both the distance from the mounting points to the ground and the enclosed shell are very tight and made what would have been considered an ideal solution not possible. So for the design portion, we split the team into 2 groups, the first of which focused on the suspension and braking systems with Sammy, Caleb, Oleana, and myself, and the second which handled the steering system and included Nicole, Josh, and Cody. The suspension team started with the hub and knuckle design so that we could work from the ground up. The knuckle is far taller than would be typically seen, however, this was the way around the physical height of the shell being a limiting factor. The bottom of the knuckle is the base of the assembly for the brake rotor, hub adapter, which is used to match the bolt pattern from the hub to the wheel pattern, and the wheel itself. Moving to the side of the knuckle is the mounting brackets for the brake calipers. Towards the top of the knuckle are 3 main connection points, the first of which is the connection for the lower A-arm. Above it is a slot and 2 bolts for the upper A-arm connection adapter, and on the side is the connection point for the steering arms. These arms are on each knuckle to provide the connection for steering the front wheels and keeping the rear wheels locked in a straight position and maintaining alignment. The braking system was designed alongside this, but not originally intended to be built. The key factor with the brakes was redundancy and the cost. The braking system was designed to have 2 separate master cylinders, one for the front and one for the rear brakes, so that if either failed, there was still a system in place along with a parking brake. The hub motor wheel mount and knuckle is slightly different as it has a hub within the motor and did not need one. The A-arms were designed along with mounting brackets to attach to the shell at specific points that were pre-existing on the car. The A-arms are threaded to provide as much room for adjustment as reasonable. A mounting bracket was also needed for the shocks, which are attached to the body and the lower A-arms. The steering team found a pre-produced rack and pinion and a collapsible steering column designed with the linkages for the steering arms, the sway bar at the rear of the vehicle, and the steering wheel. We then machined all of the parts and began assembling them on the car. There were many small adjustments that we made due to the tight space and a provided CAD model in the design phase that had some irregularities. However, the car came together fairly well. This picture on the left shows the first knuckle that we fully machined. Before moving forward on machining all 4 knuckles, we wanted to have one full assembly, so we put one together, as you can see on the right, and in the middle we have a little video here showing it working fairly well. Next, I wanted to show the mounting points. As you can see, these are hard set into the car. These were pre-existing. We did not get to choose where these went. They all have the same rough pattern. However, they're not exactly the same dimensions at each point, which is why we needed a lot of room for adjustability, including to adjust the toe camber of the wheels. In the middle was our first attempt at putting a wheel on the car. The A-arms were a bit long, so we trimmed those down and rethreaded them. And on the right, you can see a full assembly minus the shocks on the car. This is the front right wheel of the car. Once we got it on and we put the shock in, we repeated that for all 4 wheels. And here you can see the first picture we had of when we took the car off of the stand, put it on the ground for the very first time. Once we did that, we have this video showing our first test drive where we have Caleb in the car and we're just pushing it along. It rolled really well. We pushed up and down on the suspension a bit or the car itself to test the suspension. We noticed that as we turned the wheels, sometimes they would clip into the edge of the shell. So we had to modify the shell a bit and cut it back so that it wasn't clipping the wheels. We then set up a few tests in the big room at the end of the IDC, where you can see this suspension test to show us pushing the car over a 3-inch bump. Now you see that wheel snap. That is because at the time we did not have the sway bar in. However, the car was fine. Once we put the sway bar in, that was no longer an issue. Thank you for watching. This was Team 22, the Solar Racing Car Chassis.